Hey guys, Mr. Riz here to help you out on section 3.4. So we're going to be looking at solving quadratics by factoring here. So let's start warming up here. Go ahead, pause this video and try to factor each one of these expressions here. Okay, so the first one here, this is a GCF factoring. So GCF factoring, you're going to look to see, okay, we got the two terms. What do they have in common? They both have an M and an N. All right, and then if we get rid of an mn from both of these, nothing would be left over, but we wouldn't put a 1 since we're dividing, or a 0. We would put a 1 since we're dividing. All right, now on this part here, if we get rid of the m and the m, we're left with w. So there we go. The first one is mn times 1 plus w. All right, next one here. All right, we have two terms, and the one thing we should look out for whenever you see two terms with a minus sign in the middle is can you take the square root of both of these? If you can, this is a difference of squares factoring. So the difference of squares factoring is going to be two expressions very similar, except for one's plus, one's minus. And the two terms are just take the square root of both those. The square root of 4 is 2. The square root of x squared is x. So we get a 2x plus and a 2x minus, and then take the square root of the last term. Square root of the last term is 5. So we get a 2x plus 5 and a 2x minus 5. Now, when we get three terms, what we're going to do is start figuring out, okay, what numbers can multiply together to get the last number, add together to get the middle number. All right, so what multiplies to give us -5, adds together to get 4. That's a 5 and a -1. So we get an x plus 5 and an x minus 1. Now, when we have a number out in front, we are going to have to multiply these two terms together. So what multiplies together to get 25 times 9 is 225, adds together to get -30. The magic combination is -15 and -15. So we would get a x minus 15 times an x minus 15. Now, when we also have a number in front, we need to divide our answer by that number in front. And then we simplify and or slide. So simplifying the fraction here, -15 divided by 25 is a -3/5. So that's the same on both of those. And then we slide a denominator out in front. So we get a, oh, not a 3, but a 5x minus 3 times a 5x minus 3. Now, if we're feeling real fancy here, what we can do is make this 5x minus 3 squared. I don't care if you write it like this, two terms, the same thing. That's fine. If you're feeling fancy, you can square it. All right, last one here. Do the same thing that we did in the last one. We get a 2 times 4 is an 8. Add together to get 9. And then be 8 and 1. So we get an x plus 8, x plus 1. We got to divide them both by the number in front. Divide by 2. Hey, morning. Shoot. What the heck just happened here? Microsoft Teams just opened. Mouse just. Oh, you're good. I gotta pause anyways. Something. In progress. Oh, there we go. Computer decided to just run an update. That's always fun. Okay. Let's go back to tape. Oh, running another update. One more second, guys. Okay, sorry, my writing pad is messing up right now, so everything's going to be with my mouse here. So we get x plus 8 divided by 2 times an x plus 1 divided by 2. This is where we simplify. We get an x plus 4. 8 divided by 2 is 4. And the 1/2 doesn't divide, so we slide it on in. 2x plus 1. All right, let's check. Let's clear all my drawings here. Check, did we get that right? We did. Let me go back here. Oh my God, how zoomed in is everything. That's why it wasn't working. Such a, there we go. All right, so the goal here is to solve by factoring. So let's make sure we understand the factoring here. So if you were confused with the review, all right, let's set by this. GCF factoring, we try to find the largest number we can divide all the coefficients by. We try to find the largest power of each variable in common it has, and then we factor or divide each term by that. So the biggest thing we can divide 6 and 9 by is 3. This has an x, but that doesn't. So 3 is the only GCF factor. If I divide 6x by 3, I get 2x. And 9 divided by 3 is 3. That's it. All right, this next one here, what can we divide 12 and 18 by? We can divide them both by 6. They both have y's, and the highest power is just 1y. So if we divide each term by 6 and get rid of a y, 12 divided by 6 is 2, and y squared divided by y is y. All right, next, 18 divided by 6 is 3. Y divided by y is no y's. We're just putting 3 there. And next one here, 15 and 20, we can divide them both by 5. And they both have x's, and they both have at least an x squared. All right, so we're going to divide the terms by 5 and get rid of x squared. So 15 divided by 5 is 3. X cubed, take away an x squared is 1x. All right, minus 20 divided by 5 is 4. X squared divided by x squared is no x's. Just, there we go. So there we go, GCF factoring, nothing too overcomplicated. All right, next, factoring trinomials. This is where we multiply to get the number at the end and then divide or add to get the number in the middle. Now, when it's equal to 1, that's all we need to do. So what multiplies together to give us 6 adds together to get 5. Think of those combinations. That'd be 2 times 3. All right, so we would write an x plus 2 and an x plus 3. Now keep in mind, if you also have x plus 3 times x plus 2, it's the same thing. As long as the parentheses, what's inside the parentheses, are the same. The order of the parentheses itself does not matter. All right, 1 multiplies together to give us 10, adds together to get 7, 5 and 2. Always think about what multiplies first, not what adds. All right, so we get x plus 5, x plus 2. All right, and then just be careful with the negatives. What multiplies together to give us a negative 10, adds together to get negative 3, be a negative 5, and a positive 2. So we get an x minus 5, x plus 2. See how the other two, see just the slight difference here that plus made and the minus made between these last two problems. All right, and then when we have a term with a number in front, what we need to do is multiply together to get the figure out time. So we got 2 times 3 here. So what multiplies together to get 6? Oops, 6. Adds together to get 5. That's a 2 and a 3. So we're going to write down those special numbers, 2 and 3. And then what we need to do is to divide by the number in front. So we're going to divide by 2, divide by 2. All right, so 2 divided by 2 is 1. Slide this one over in front. Since 3 does not divide by 2, it doesn't simplify. We just slide it all over. That becomes a 2x plus 3. All right, very similar problem here. This time it's going to be what multiplies together to give us 6, adds together to get 7. That's a 6 and a 1. So we get x plus 6, x plus 1. Divide them both by 3. That was the number in front of this problem. 6 does divide by 3. That is 2. 1 does not divide by 3, so we slide it on over, make it a 3x plus 1. Alrighty, next problem here. What multiplies together? 4 times negative 8 is negative 32. Adds together to get 4. Now, actually, we're going to cross that out. This one we see here, we actually have to do GCF. Because can we divide all those numbers by something else? Yeah, we can divide them all by 4. So I'm going to rewrite this problem as 4 times x squared minus x minus 2. So now what we're going to do is what numbers multiply together. This is a 1 in front. A negative 2 adds together to get a negative 1. It's a negative 2 and a positive 1. So we have our 4 times the parenthesis x minus 2 times x plus 1. This one's always tricky. People will see if you try to jump to this, you actually get a GCF. You'll get these right roots. You'll get the right roots, but you technically don't factor it the right way. So I'm not too worried about here when we solve. You'll still get the same answer, but it's technically not factoring the right way. Okay, so if we remember here from graphing, if we want to solve a quadratic, we want to figure out where the equation equals 0. To do this without graphing, what we can do is we can factor the expressions, we can get our roots here. What we just need to do then is to figure out where do each one of these individual roots equal 0. Because if I can figure out the number that makes this parenthesis 0, it doesn't matter what value this becomes, because 0 times whatever this is going to be 0. And vice versa. If I can figure out what makes this parenthesis on the right 0, if I plug that same number into here, it's going to be some number, but whatever number that is times 0 is going to be 0. So we're going to find our two answers by finding our two factors. Okay. And so, yeah, let's go through some examples here with this. So first thing we got to do is make the problem equal to 0. So we're going to subtract this over here. We'll minus the x, and we get a 12x squared minus 3x equals 0. All right, so if we got to factor this, this one is a GCF factoring. So what can we divide 12 and 3 by? We can divide them both by 3. And that has an x squared, that has an x, so we can take a 3x away from both of those. All right, so we get 12 divided by 3 is 4x, and then 3x divided by 3x is 1. Okay, so now what we're going to do is technically this 3x is by itself in a parenthesis. We are going to set each parenthesis equal to 0 and solve that. Do not overthink this first one. If I have 3x equals 0, if I divide 0 by 3, I get 0. So there's one solution. Now on this one here, if we go through and make 4x minus 1 equal to 0, to solve this here, we get 4x. I would add the 1 over, and then divide 1 by 4, and we get 1/4. So there are two solutions. We can find these without graphing, and we can get exact answers. Because remember with graphing before, sometimes we get decimals, and those decimals sometimes are hard to figure out. 0.25 isn't too bad, but if we had 0.14287, like something like that, one that you're not familiar with, it'd be easier to figure out exactly what that is by factoring. Okay, pause this video, give this one a try. Try this one on your own. All right, let's check. So we got to minus the 18 over. So we get x squared minus 6x. We take negative 9 and subtract 18. That's negative 27. So equals 0. We got to factor this. What numbers multiply to get negative 27? Add together to get negative 6. That would be negative 9 and a positive 3. So we get x minus 9, x plus 3. Now, a lot of people will get the factors mixed up with the solution because they are very similar, but they are not necessarily the same thing. All right, because we need to take each factor. I got to make x minus 9 equal to 0 and solve that, add 9 over. So x would equal a positive 9 is a solution. And x plus 3 equal to 0. That's our other one we need to solve for. X would equal negative 3. That's our other solution. Now, you might see here and realize that real quickly that the roots, these factors, are the opposite of their solution. And that's totally normal. That's good. Okay, we can use this with story problems as well. All we need to do is to plug in this information here. So the displacement of the car is going along here. All right, it says the displacement, the car moved 605 feet, that's how far moved, is equal to the velocity that it changed. And so accelerated from 35 to 45. All right, so that'd be 45 t plus 1/2. Oh, this is in the way. 2 feet per second. Okay. 2 times t squared. All right, what we need to do is to solve this here. So we're going to set this problem equal to 0. So I'm going to minus the 605 over. Now, half of 2t squared is just t squared. We get plus 45t minus 605 equals 0. What we're going to have to do is figure out what number multiplies together to get negative 605 adds together to get 45. I'm going to pause this and do a lot of guessing and checking. All right, I think I made this mistake before. This is in miles per hour, and we're talking about feet. So if I were to convert this, this would be 116 feet per second. So sorry about that. So that means we got to figure out what multiplies together to get 116, and that would be a positive 121 and a negative 5. All right, we set both of those equal to 0. So t would equal negative 121 or a positive 5. And if you think about how long does it take, not negative 121 seconds. Okay, go ahead, try this one here, try to figure this out, solve this one by factoring. So what I would do first here is to see, can we get lucky? Can we divide everything, one of those by 16? If we can. So 1712, does that divide by 16? It does, it's 107. Does 640 divide by 16? It does. Okay, so if we can make our life easier, let's do that. So it is, I'm going to divide everything by negative 16. So we get x squared minus 107x plus 2790. What we want to do is figure out what numbers multiply to get 2790 and add together to get negative 107. And what we can do here, since this is multiple choice, let's just guess and check. All right, so multiply. Does 11.25 times 1550 multiply together get, no, it doesn't. All right, what about 45 times 62? Does that multiply to get 2790? It does. We add them together. Does that equal 107? It does. So B is the one where it multiplies together. If I did 45 times 62, 2790. 45 plus 62 is 107. Now keep in mind, both of them technically would have been factored as negatives, but when we solve them, we get positive. Okay, we can check here. These ones do not add together to get 107. Those ones definitely do not add together to get 107. Okay, let's keep this going here. Let's get a little bit more complicated and solve these ones here. All right, so we're going to make this equal to 0. So we get 3x squared plus 5x. If we subtract the 17 over, we get a minus 2. 0. So what numbers multiply together to give us negative 6 adds together to get 5? That'd be a 6 and a negative 1. So we get an x plus 3, or no, x plus 6 x minus 1, divide them both by 3. So we get an x plus 2 and a 3x minus 1. Okay, so now we need to solve both of those. We get x plus 2 equals 0. We subtract 2 over, we get x equals negative 2. There's one solution. And then the 3x minus 1, we set that equal to 0. We need to add the 1 over, so 3x would equal positive 1. And divide by 3, we get a fraction of 1/3. Nice. All right, pause this video. Try this next one on your own. So we have 4x squared plus 12x. We subtract 13 over, we get minus 40 equals 0. Now, you could go through and do this the long way. You can figure out what two numbers multiply together to get negative 160 adds together to get 12, or we can divide everything by 4. If you can do that, make your life easier. So we get a 3x minus 10. All right, if you do that, if I divide everything by 4, I get what multiplies together, negative 10 adds together to get 3. That'd be a positive 5 and a negative 2. And then when we solve, we basically get the opposite there. We get x equals negative 5 and x equals positive 2. Now, if you did this the long way here, you would get, what would it be? It'd be a 20 and a negative 8. And when you do those, you would have to divide both of those by 4. What's 20 divided by 4? 5. What's negative 8 divided by 4? 2. Negative 2. So you get the same answer. It's just harder to think about when the numbers are larger. Okay, so the key concepts here is to go through a factor, find those roots. Yeah, so something like this one here, if we wanted to go through and factor this, okay, the differences of squares, if we get x squared minus 81 equals 0. So you can figure out what multiplies together to give you negative 81, adds together to get 0, or you can see, can we take the square root of both of those? Yes, we can. We'd get an x plus 9 and an x minus 9. So x would equal positive and negative 9. I'm going to put a plus or minus symbol because I'm lazy. But that's how it says. The plus or minus means we have a positive version of it and we have a negative version. You guys want to try this one on your own? You can. Let's see. What I would check on the calculator, can you take the square root of 529? Yes, you can. It is 23. So we would get a positive and a negative 23. Let's go through this one here and check. So let's see. We're going to have to minus the 26 over and add 13 over 16y squared. If I subtract 26 from negative 22, I get negative 48y. If I add 13 to 20, that's a 36 equals 0. Okay, can I divide them by anything to make my life easier? 36 does divide by 6. Divide everything by 4. Yeah, I can divide everything by 4 and get a 4y squared minus 12y plus 9. But that's as far as we can take it here. So what multiplies together to get 4 times 9 is 36. Adds together to get negative 12. Oh, that's a negative 6 and negative 6. Right, so we get a y minus 6. We'll divide that by 4. We get a y minus 6 divided by 4. Now, technically, we should simplify these before we slide them. But if you think about it, if we're going to solve this, are we going to get any answer different in either one of those? No, we're not. And if we're going to solve them, it really doesn't matter if it's not simplified yet, because we're going to solve and we're just going to add that over. So y is going to equal 6 over 4, which now we can reduce at the end and get y equals 3/2, 3 over 2. If we were to go through and simplify this the proper way, yes, we would get 3 over 2. We'd put the 2 over 2 and get a 2y minus 3 on both of these. And if we wanted to solve both of those, we get the same answer of 2y minus 3 equals 0. We would add 3 over, divide by 2. We still get the same thing. So it's one of those things. kind of notice right ahead, like, hey, these are the same, exact same things. I'm not going to solve both of them if they're both the same thing. We get only one answer here. Remember when we solve quadratics, that can happen. Sometimes you can get one solution. Sometimes you can get no solutions too, or no real solutions. All right, if you guys want to pause the video, check this one out. See if you can do this one. All right, that one should be 1. If you minus the 10x over, that's a negative 32. If you add 1 over, that's 16. You can divide all of those by 16. And you get an x squared minus 2x plus 1. So it can be an x minus 1, x minus 1. X would just equal 1. All right, now, how do we get complex things here? Now, if we know, if we were to take the square root here, right, we can't take the square root of negative, but we can write it as imaginary terms. The square root of 144 is 12i. And if you remember with factoring, that we do get a positive and a negative version. So we are going to kind of combine those two facts together is, yes, if we have the x squared by itself, we could factor it or square root it. We just need to remember if it's negative, we get an imaginary solution. And technically, because of factoring, what two numbers multiplied together, it's a difference of squares. We are going to have a positive and a negative answer. So we get a plus and a minus 12i. There are our two solutions. All right. There we go. Thank you guys for watching. I know this is a longer video. I hope you guys have a great rest of your day, and I will see you.